So hello everyone, welcome you all to this new video. So in our previous videos we had left with the problems related to work done, right? Application of line integral, work done. We have solved two important problems in the previous session. So we are going to continue with the problems only in this video. So we are going to solve two very important problems in this video, okay? So the problems are lengthy, so I'm not going to waste time. Again, those who have not seen those previous videos, please go and watch it. It is available in the channel, okay? So this is the first question of this video, question number 3. Find the work done in moving a particle in the force field mentioned as force is equal to F vector is equal to 3x square I cap plus 2xz minus y into j cap plus z into k cap. And there are two conditions given here. This force is moving firstly along the straight line from the points mentioned, that is 0, 0, 0 to 2, 1, 3, and next is along the curve defined by x square is equal to 4y, 3x cube is equal to 8z from the interval x is equal to 0 to 2. Okay, so these two are the conditions given. Okay, let us solve one by one. First condition they have given is along the straight line. Okay, along straight line from the points 0, 0, 0, 0 to 2, 1, 3. For that we should be writing the equation of slope in order to move further, that is t is equal to x minus x1 divided by x2 minus x1. So this you might be learning in your first PU. Y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. Okay, in this we are going to substitute with some of the values. That is, first the values of x1, y1, z1, x1, y1, z1 and x2, y2, z2. Okay, so let us do that substitution now. X you keep it as it is, that is x minus x1. x1 is this point 0. This is x1, y1, z1, x2, y2, z2. Okay, and x2 is 2 minus 0 is equal to y minus y1, that is y minus 0 divided by 1 minus 0 is equal to z minus 0 divided by 3 minus 0. Okay, so that would be equal to x minus 0 is x, 2 minus 0 is 2, x by 2 divided by y by 1 equal to z by 3. Okay, so this is the slope t. So from this we could be concluding the values of x, y, z as follows. That is, therefore, if t is equal to x by 2 separately, if t is equal to x by 2, then we would be getting the value of x is equal to 2t, one thing. And if t is equal to y, then we would be getting the value of y is equal to t. And if t is equal to z by 3, then the value of z would be equal to 3t, right? So by this we got one conclusion, that y is equal to t, right? So what we could be doing is, in place of y is equal to t, so in place of t here in this term we could be writing x is equal to 2y. Okay, so here in place of t I am writing a y. So what I am doing is, the whole equation, since I have got one term that is y is equal to t, so what I am doing is, the whole equation, in order to solve it using integration, what I am doing is I am just making that whole equation of f dot dr in terms of y. Okay, as I have done in the previous one problem. So what we would be getting here, if y is equal to t, so here we would be getting x is equal to 2y, and dx we would be getting, that is differentiation of dx with respect to y, that is we would be getting 2 dy. Similarly, y is equal to t, keep it as it is. Z, okay, z is equal to 3t, that is 3y, and dz what we would be getting, 3 into dy. Okay, so these are the values of dx and dz. Now what I am doing is f dot dr. F what they have given in the question, 3x square I cap plus 2xz minus y j cap plus z k cap, right? And dr dx I cap dy j cap dz k cap. So what we would be getting, f dot dr 3x square dx plus 2xz minus y dy plus z dz, right? This we would be getting f dot dr, but whatever we have substituted here, the values, right, that we are going to put it in this equation and make this whole equation in terms of y only, okay? Since we got one conclusion that y is equal to t, so f dot dr is equal to 3 into x square, okay? What is x is equal to 2y, so 2y the whole square into dx. What is dx is equal to 2 dy and plus 2xz, that is 2 into x is equal to 2y and z is equal to 3y minus y into dy as it is plus z. What is z equal to 3y and dz is equal to 3 dy, okay? So like this we have written it now. Now just simplify this part, that is 2y square, 2y the whole square, that is equal to 4y square, right? So 4 into 3 is 12 and 12 into 2 is 24, and here we have y square and here we have dy, okay? So 24y square dy plus 2 to 3, so 2 into 2 4 into 3 12 y square minus y into dy plus 9y dy, right? So if you solve this, you would be getting 24y square dy plus 12y square dy, I am multiplying, minus y dy plus 9y dy. So 24 plus 12 y square dy, that is equal to 36 y square dy, and here we would be getting 9 minus 1, that is plus 8 y dy, okay? So this is the value of f dot dr finally, 36 y square dy plus 8y dy, okay? We have simplified this using the straight line equation, okay? Just go through it again, and now we are going to take its integral and see what answer we get, okay? Let us take its integral quickly now. Integration of f dot dr around the closed path, okay, and the limits are from 0 to 1. Why the limits are from 0 to 1? Anybody can tell me? Because we have written the whole equation in terms of y, okay? So these are the limits, that is 0 to 1, okay? This is x, y, z, right? So we should be considering the limits of y, because we have written this equation in terms of y, right? Because y is equal to t we have got. So the limits would be from 0 to 1, okay? (36 y square dy plus 0 to 1 8y dy, right? So solve it. 36 y square, we can write it as y cube by 3 integration, so limits are from 0 to 1 plus 8, and integration of y is y square by 2, limits 0 to 1. So 36 into upper limit, that is 1 cube by 3 minus 0, so 1 by 3 plus 8 into 1 square by 2, that is 1 by 2. So 2 1s are 2 4s are 3 1s are 3 12s are, so you would be getting 12 plus 4, that is integration of f dot dr, or the work done w, is equal to 16, okay? Or simply we can write SI unit of work done is joule, right? If you want, you can write joule, okay? But it's in maths, so you could be writing simply 16 units, okay? Yeah. First question: use Green's theorem to evaluate the particular integral mentioned here, that is integral over a closed surface xy plus y square dx plus x square dy, where C is the closed surface curve made up of line y is equal to x and parabola y is equal to x square, okay? So this is the question here. I have told you should be plotting graph, right, with the given conditions y equal to x and y equal to x square. Okay, so here if you observe carefully this term here, the general equation of Green's theorem is what? M dx plus n dy, right? That is equal to double integral over a region dou n by dou x minus dou m by dou y dx dy, right? So this is the formula for Green's theorem, right? So here they have given the left hand side part, where this term is equal to the, in place of xy plus y square we can write it as m, in place of x square we can write it as n. Okay, yeah. So we'll solve that. How to solve, let us see. Before that, plot the graph from the given conditions y equal to x and y equal to x square. Okay, let us see how to plot it now. First, this plot is very important for the integration limits. Okay, in order to calculate, in order to see what are the limits of x and y, these things play a vital role. Okay, that's how I'm going to tell you. First, let us draw a parabola y equal to x square. Okay, since parabola is drawn like this, okay, you know that this is y-axis, x-axis. For all the values of x here, these are the values of x. Okay, the y value would be equal, that is x square. So 0 square is 0, 1 square is 1. If the value of x is 1, so 1 square is 1, also minus 1 square is 1, so y would be equal. Okay, so like that we would be getting the conclusion that like this the parabola would be looking y equal to x square. Also they are mentioned to draw x is equal to y line, that is this part, slope part. This is the line of x equal to y. So this is from the origin. You should be drawing one line perpendicularly, straight line, so that the value of x would be equal to y. That is 0 0. Here 1 1, 2 2, 3 3, 4 4, so on. Okay, the values of x and y are equal. Okay, this is at 0 0. If x is 1 here, y also should be 1, so this would be intersecting here. If x is 2, y is also 2, it would be intersecting here, and we would be forming one slope. Okay, so this is the line of x equal to y. They have given the two conditions, y equal to x and y equal to x square. For that we have drawn the lines. Now where the two curves right are intersecting, right, that region you should be shading here. Okay, why? Because from that region you are going to check out the limits here. Okay, so I am just going to extend this parabolic curve here. Okay, so that I could shade well. Yeah. Okay, wherever it is intersecting, the point of intersection you should be checking for the limits. That I am going to tell you now. That is to find the limits of y. Okay, for which term is common, right, in the given condition, in the given question, that you should be checking the limits in the graph. And the other term, that is x and x square, you should be solving manually and checking. Okay, to find the limits of y from x tending to y. Okay, wherever the curve is meeting at x, right, from that point, wherever the curve is meeting at y, you should be drawing one perpendicular, so that the limits would be from this starting point x here. In x axis it is touching here, the curve here is of x square, to ending point is this, that is the curve here is x. Okay, so the limits of y are from x square to x. Okay, now let us check the limits of x here now. For that you should be solving manually using Green's theorem. Okay, hope it is clear. So now by Green's theorem, solve it now by GT stands for Green's theorem. So while solving the problems, this is the abbreviation I am going to use in all the problems. So GT stands for Green's theorem. We know that m dx plus n dy, right? Here in the given question, m is equal to xy plus y square and n is equal to x square, right? So now in the right hand side we have one term dou m by dou y. Okay, so let us solve that. That is, we should partially differentiating this term with respect to y. So in these two terms, both the sides we have y. So differentiation of y is 1. Here we have only x now, plus differentiation of y square is 2y. Similarly, in the other side we have dou n minus dou n by dou x. That is, dou by dou x is n, that is 2x. Now in order to find the limits of x here we have y equal to x and y equal to x square, right? So how we can find? You can see that x is equal to x square from these two conditions, right? So we got one rule here. So what we could be doing, x minus x square equal to 0, or x into x minus 1, just have taken x common, okay? So we would be getting this term, that is equal to 0. So we would be getting x equal to 0 and x minus 1 equal to 0. So x equal to 0 and x equal to 1. So you can say that x tends from 0 to 1. Okay, so hope it is clear. So the limits are, I'm writing it here again, limits. These limits play a vital role. For x, limit is from 0 to 1, and for y, from the graph, the limit is from x square to x. Okay, so hope it is clear. Now let us do the integration part, that is this part, integration of m dx plus n dy, that is integration of m dx plus n dy. Is equal to double integration of dou m minus dou y, sorry, this term dou n minus dou x minus dou m by dou y into dx dy, right? So this is the formula. According to the question, the limits are from, so here we have dx dy. So first we have dx, so in the first integral write the limits of x, that is from 0 to 1. The second are from limits of y, x square to x. Okay, dou n minus dou x, dou n minus dou x is 2x minus dou m by dou y is x plus 2y. So 2x minus x plus 2y, 2x minus x is plus x, so we are left with x plus 2y dy dx dy. Okay, so step by step let us solve it now. I'll do it in the next page, that is x square to x, 0 to 1, x minus 2y dx dy. Okay, so you hope you know to solve the double integrations and all. First do the inner part, that is x square to x, keep it as it is. Take the integration of this part, that is x minus 2y with respect to dx. So x dx is x dy is xy minus 2 into y. The integration of y is y square by 2. So 2 would be getting cancelled, you would be left with only y square. Okay, and now the limits are from I made a mistake, sorry, let us solve it again. X square to x, x dx, that is x square by 2, and 2y dx, that is dx, that is 2xy. Zero to 1 limits dy. So x square, so do the upper limit minus lower limit, that is 1 by 2 minus 2y minus 1 by 2 minus 0 dy. So x square to x, 1 by 2 minus 2y minus 1 by 2 dy. So 1 by 2 goes. We are left with 2y dy. Okay. Now minus 2, take it common. X square 2x y dy. So that is minus 2 into y square by 2 x square and x. Upper limit, that is x square minus x square, and in place of y is x square, so x to the power 4 divided by 2. So 2 gets cancelled, so we are left with x to the power 4 minus minus plus, so x to the power 4 minus x square. Okay. So this is the required answer. So hope it is clear.